Hello everyone, welcome back again to the online NPTEL course on research methodology for planning and architectural studies. So in this particular week, we have discussed about different literature review, the types of literature review by which you can identify the research gap, and also you can compare the past literature with your own research that you are going to conduct. So in that case, we have discussed about the advantages and disadvantages of bibliometric analysis. We also discussed about the SLR, the systematic literature review. Now today we will discuss another type of literature review, which is much more specific to the quantification of the literature and the findings, that is meta analysis. So with that, our lecture number 14 will discuss about the meta analysis, its advantages and how to do it. So in this lecture, what we are going to learn, first we will get certain idea about meta analysis, what exactly it is. Then the advantage of meta analysis step before conducting the meta analysis. So it is not that okay, straight away you can do this analysis. We have to extract quantitative information out of the past literature. So for that there are some prerequisite, there are some steps before you actually conduct the meta analysis. Then step involved in meta analysis, then method of analysis, then we will also look at some of the representation of that meta analysis, and then we summarize our understanding at this end of this particular presentation. Now what is meta analysis? It is a systematic review of quantitative studies in the selected field which additionally compares the empirical results, is known as meta analysis. So we have seen in systematic literature review that with our inclusion exclusion criteria we can finally come to a number of papers which are most relevant for your field of research, and then you go and develop your deep understanding about those past studies, the literature, the content that they have published. Now in this particular case, again it is a systematic review, but for quantitative study where there are certain kind of empirical results, and here this particular case we compare the empirical results in terms of certain kind of similarity, dissimilarity. We will discuss in detail the effect size and all, that is referred as meta analysis. So in other way, Dix et al 2023 mentioned that meta analysis is the statistical combination of results from two or more separate studies. So you may find that you want to work on something called flood resilience in urban area, and there are certain sort of empirical studies which have been done in several other part of the country or maybe outside the country, and then you will find that they have reported certain sort of correlation among the chosen variables, that okay, if it is some development of a correlation analysis between certain independent variables that they have considered in their studies, and then you compare that with another study which almost taking the similar number of parameters, and then they also done certain sort of analysis. So they also establish certain correlation between the independent variables, but obviously in that case you may not get the exact same value statistically. Maybe both are significant, but they may not be exactly same in terms of its decimal points or exact value. So this meta analysis, what will do in this aspect, will compare these two particular studies where they are reporting certain correlation among two known variables, and then its association with maybe the sample size or maybe some other statistics. They compare and then try to bring out certain kind of output in this particular case. Meta analysis includes a set of methods that can combine quantitatively the evidence from different studies in a mathematically appropriate way. That say a study is trying to understand that child education and then parents income. So if these two variables are taken in 2-3 studies and they try to establish certain kind of correlation among that. So maybe the study 1 considered particular income group, or maybe study to consider all income group, or maybe in some cases study 3 considered a different geographical and cultural background of the population. So in all such cases there are certain correlation they have reported, that it's depending on the income, that probably the hypothesis is something like, if people are having higher income, so they intend to go for some education in some better school and colleges and other thing. So such kind of aspect or such kind of argument we can qualitatively discuss obviously. But in that case, if this is some empirical proof by through regression, by correlation, or maybe in some cases we just getting the mean value of the data set and the standard deviation, and then probably we extract that information out of all 3 literatures which talks about similar variables, and but their values are different and their sample considerations are also different. So if we want to combine the result and try to see that okay, what is the overall combined weighted results out of this, that okay, the effect size that we will calculate for this kind of 3 studies based on the correlation, based on their standard deviation, all other parameters for 2 variables which are similar for all these studies. So that is possible in this particular meta analysis. Now advantages of meta analysis over other 2 like bibliometric and SLR. So in this case it improves the precision. Many studies are too small to provide convincing evidence about interventions effects in isolation. So in such cases, like maybe some study just consider a very small sample size and argue that okay, this is the correlation they found between say parents income and the child education. The same example we continue. So in some cases it is obvious, and it was found in many such instances, that estimation is usually improved when it is based on more information. So if you have a very smaller sample size, if you only do a particular group size, then probably it may be a biased outcome, or maybe it is not that much clear evidence out of that particular phenomena. So normally if you have more information and if that can fit well into your analysis, you can expect a better outcome out of it. Along with that, obviously it will answer the questions not posed by the individual studies. So as because we are comparing 2-3 different studies of similar nature, or maybe where all the papers they have talked about same variables and they reported different correlation value or different their associated values, but it is definitely the primary studies often involve a specific type of participant and explicitly define the interventions. So whatever the strategy, and for change of that strategy, how things will move, all this scenario that may be different for different studies. Studies with different characteristics allow investigation of consistency of the effect, that how consistent it is. Suppose if I say that okay, there is a strong relation of income and then choice of parents to send their children to like good school and colleges. So in such cases, like maybe some of the studies saying that there is a positive correlation or there is something just the reverse. So there is some inconsistency, but wherever like we will find certain findings that okay, they are saying that it is highly correlated or it is not that strongly correlated, that a correlation value is say close to almost zero point 0.8 or something, is a high positive say correlation, where some studies say that it is having correlation but very poor, it is the value is less than 0.5. So in such cases, across different study, we can definitely measure their effects through meta analysis. Additionally, it also settles the controversies arising from apparently conflicting studies or generate new hypotheses. So, if there is conflict also, suppose I say that in one case that all the studies, even the values are different in terms of correlation, but they are saying there is a strong positive correlation, but it may happen that some study may come up with a negative correlation. So, in such cases the studies, they are conflicting their findings. So, here we can see the combined effect of it, and also out of that we can create certain kind of new hypothesis that okay, for this kind of study or this kind of relationship, if we want to measure, so probably this should be the a consideration, or this should be the probably the overall effect size or the values that we are expecting. So, statistical synthesis of findings allow degrees of conflict to be formally assessed, and also the reasons for different results. It may be because of the biasness in the sample, or maybe some study they have done at aggregate level analysis that they do not consider any kind of stratification among the sample. So, that may be one reason, or maybe it is depending on the sampling technique by which like that biasness can come. But in all those cases, it is something that the final result that they have reported will synthesize that through the meta analysis, and then by that it will be explored and then quantified. Now, steps before meta analysis. So, to conduct meta analysis we need some quantifiable data, some extract out of that, because the data that the way it is represented in different papers may be different. So, we have to extract that information in our desired format, that whatever the values or statistical indicators or indices that we are going to consider, whether it is like correlation, whether it is mean standard deviation, or else we are thinking for something else to be looked at. So, for such cases we have to extract the same information out of the papers that we want to compare and try to see the combination and combined effect. So, before that what we need to do, we first, again this is a typical need for any review, that all of a sudden you will not start the review. So, for such cases what you need to do, we have to first formulate the research questions, or in this case better to say the review questions, that what for you are searching. Suppose if I want to study the same, that okay, the the relationship between the parents' income and then choice of school for sending their children. Okay. So, in such cases we have to have certain kind of keywords well thought of, and then we start searching. Then after that we specify the eligibility criteria for your selection of the review. So, in this case we have seen in SLR that the inclusion criteria, that maybe in these cases that some papers are very basic papers. So, we have to go for retrieve that paper, or maybe some papers which are not written in certain English language, say for example I am considering. So, I can remove that, or some papers which are outside the duration that we are thinking of, or maybe some papers which is something that we only try to consider the quality of journal. So, we only consider the publications which are having say Q1, Q2, that kind of quartile, or maybe some impact factor. So, it's based on the researcher's judgment, and then the inclusion exclusion criteria that the researcher will impose on this kind of search. So, specify those kind of eligibility criteria to finally get the series of paper like number of papers that we can get. Then we talked about this prisma in detail, where we have such kind of sources from different documents, different published article and all, and finally we come up with certain numbers which are like, say x number of papers which are most relevant, and in depth understanding is required out of this kind of papers. So you can start with say 100 papers in general. So after reading the abstract, after reading the conclusion, then you may still screen it. So the in Prisma actually you have that screening process, and finally you come up with the final number where you go for a in-depth review. Now once we identify those papers, then you have to extract the appropriate data. Some of the papers you will find that they are much more on the theory or concept. So those papers may not be adequate enough to get into the meta analysis, because you need some quantifiable data. So out of that you find that okay, out of X paper, maybe Y number of papers are having those kind of numeric data, right. So this numeric data you include into your consideration. Then considering the risk of bias and identifying potential sources of bias. So if you find in such cases the results are distinctly varied, so then you have to also consider the possible risk of biasness. So maybe something it can come up with something like based on sampling, based on sample size, based on the time and the other context as well. Next you compare the planning interventions that they have used in their intervention, those strategy or scenario, and then that also you need to consider, because if they are totally different, so definitely the outcome of those papers are also probably not comparable. So we have to see that what intervention they are making, whether they are going to go for the entire population data, or whether it is a sample and then within the sample there are certain stratification. So in such cases, like maybe if some kind of income level that is considered for the parents, the given example that we are talking about, the relationship between the children's education, the sending children to school and the parents income. So in such cases, like again if we add some more attribute or more stratification, and we can also do like in that way that geographical distribution, or maybe we can consider that how it is spreaded over different geographic location, and is there any such kind of influence. So there will be some sort of spatial and some non-spatial attribute which may govern the selection of a school for the children. So in such cases definitely we have to look into those papers that we consider, and then we try to analyze, okay, these 4 papers or 5 papers probably their overall context are same. So hence we can consider them for this kind of meta analysis. Now deciding what data would be meaningful to analyze. So that is why I just mentioned that we need to understand that what we are going to use for our meta analysis. If the paper is something totally different out of the context compared to the other one, so we cannot compare it in that way. Now after that, the steps that involve in meta analysis, this is very important slide for all of you. So step number 1, a generic statistics is calculated for each study. So generic, why it is generic, that statistics we will get from each of the paper of consideration. Suppose I consider only 4 papers for that topic, the same topic of the child education, sending childs to school and the parents income, and then we just calculate the general statistics to describe the observed effect size in the same way for every study. So it is something again you can only compare orange with orange for the taste variation or the size, but you should not compare orange with a watermelon. So similarly in this case the generic statistics to be determined by the researcher, and then which are being reported in the paper, or we can extract it, we can calculate it from those papers, we will select that. Next, the standard error of generic statistics. So, whatever statistics that we are going to measure, that if something, it is the effect size. Okay. So, for effect size we just many time we just calculate the effect size as the difference between two values, the mean values, and then divided by standard deviation. So, there are different way to calculate the state statistics, and then definitely for those kind of estimation there will be some kind of standard error, and then that is used to derive the confidence interval of the each result, which determines its weightages in the meta analysis. So, that means when we calculate the state statistics out of the information, we will also have the standard error of that estimation, which will determine the lower bound and upper bound of the confidence interval, and which effectively help to determine the weightage of that particular study, of that particular state statistics. After that, a summary combined intervention effects estimate is calculated as a weighted average of the intervention effects estimated in individual study. So, after that we go for a weighted average option for calculating the intervention effects through the generic statistics for the each of the studies. So, in this case, if there are 4 studies, we calculate it. Then the variation among the results of the separate study is assessed to check the compatible with random variation, or whether it is a large enough to indicate the inconsistency. So, if the variation is little less, that somebody just found it like 0.35, you found it 0.32. So, statistically it is just some small difference, but if you get certain statistics which is largely varied, like the perception is totally different, if you ask like the same questions to you just classify the information, and then you ask father the aspect, and then the mother the aspect. So, maybe in such cases, like you may get different answers for the decision on sending children to a school. Maybe if the case is something that where you consider the distance of the school. So, maybe like in such cases you may get different answers from mother and father if you want to study. So, in such cases, like similarly for some studies you get certain kind of this kind of generic statistics you calculate, and then you try to compare the weighted average generated through that standard error that of that estimate, then you will find that okay, maybe there is a heterogeneity exists. So, that will definitely help to understand the similarity and dissimilarity among the findings of the papers who are talking about the same variables, the relationship between the variables or the correlation among the variables, the impact of one variable to the other variable. So, in all such cases, this will help you to understand the homogeneity and heterogeneity among the findings. Now, let us discuss one after another the steps that we need to follow for the meta-analysis. Calculating generic statistics. So, normally effect size or treatment effect for each study of our consideration. So, in this case, what is effect size? So, the index used, so effect size is nothing but one index to quantify the relationship between two variables or difference between two groups in primary studies. So, primary studies means the studies that we have considered, right. So, the actual who reported those kind of findings, they are called primary studies. Now, when this index quantifies the impact of deliberate intervention, like the two groups mentioned above being before and after intervention group. So, maybe in that case we do some kind of before after analysis. So, it is called treatment effect. So, effect size is one index which is quantifying the relationship between two variables or difference between two groups, where the treatment effect is something like you go for the before and after the intervention. The generic statistics is estimated based on type of result generated by primary studies. So, generic statistics may not be same for all the studies. Say for example, we can have something like with the studies reporting mean and standard deviation, right. So, mean and standard deviation, what exactly it is? So, if we consider some data like distributed like normally, so we will have a larger share which is like a mean value, say for example, this is the lower value, say this is 20 and this is 80 and this is the 50. So, maybe in such cases like you get the numbers or the probability or the value of certain statistics decompose here at the middle. So, this is nothing but the mean, and now when you get the individual value, okay, so for that there is some deviation from the mean. So, that deviation from the mean value is computed in the standard deviation. So, standard deviation, if it is a plus 1, so that is above the mean. If it is like standard deviation minus to a number, so that will be like mu minus sigma. So, if mu is the mean, so you can have the values like mu plus sigma or anything. So, for that you will say that okay, there are certain kind of deviation. So, if average or the mean value of say performance of any student in the class, if it is like say 70, say for 70, so you will find that okay, the maximum students are around that particular number 70, 71, 72. There will be some student probably scoring even 90 and some student maybe below 40. So, but they are actually having much deviation from the mean. So, for such cases like the deviation in case of 90 it is plus 20, if it is 40, so it is minus 30 in such case. It can be some study where it is representing the binary data, or maybe it is something like the correlation between two variables. Now, whenever you go for binary data, then normally the generic statistics that we develop out of all primary studies is log odds ratio. Whenever you go for a means and standard deviation, we go for standardized mean difference. So, where we can use the Cohen's d statistics, or maybe where you can have this kind of bias correlated standardized mean difference, where you can go for Hedges G statistics. So, these are some state statistics by which we can calculate the effect size. If it is a correlation among variables like parents' income and the decision, so in such cases we have the Fisher's jet as your generic statistics. Now, once we complete that particular part, so that means for each study we have the values of the generic statistics and also the correlation. So, this is correlation and there maybe we can give this is some statistics. Next step is the calculating weight of each study. The precision with which we estimate an effect size can be expressed as standard error or confidence interval. So, whenever we have the standard error, so lower limit and our upper limit, or lower bound and upper bound, so we calculate the confidence interval for that. The precision is driven primarily by sample size, with larger study yielding more precise estimate of the effect size. So, we discuss this particular part that sample size play a crucial role. So, if you only go for a minimum sample size and then if you want to capture certain more input or maybe more insight out of that, so there might be some sort of issues. So, for that you need to make your sample size good enough to get the precise estimate. Studies that yield more precise estimate of the effect size carry more information or assign more weightages. So, definitely whenever we have more precise estimate, that will be assigned in more weightages in the meta analysis. Now, say for example, calculating the summary intervention effect. So, say for example, we have study A, B and C. So, then we know correlation 1, correlation 2, correlation 3 and then corresponding value. So, if I denote it with the x, so x1, x2 and x3. So, these are the input for the meta analysis and there are softwares like where you can use it, or maybe in some cases this kind of statistics you can also do manually. So, through that you go for this kind of summary of that Fisher's jet and then we go for a summary correlation, that overall combined effect. So, that is individual one derived for each study and then we will get a combined one. Now, after that the step number 4 is interpreting variation in the effect size. So, in such case what we do, the interpretation of variation in the size can be done in two ways, either using the fixed effects model or random effects model. So, there are options to select. So, what is fixed effects model? So, in fixed effect model assumes that there is one true effect size which underlines all the primary studies in the analysis. In this case the numbers are like 3, and that all differences in observed effects are due to sampling error, right. Random effects were in contrast assume that true effect could vary from study to study. So, it is not a particular reason like sampling error or something, because studies will differ in terms of mixed participant and also the implementation of different interventions. Among other reasons, there may be some different effect size underlying different studies. So, this is something we need to take care, and then in such cases what is happened that all of which will be distributed among the sum mean value and all. So, in such cases random effects model there you get a different kind of statistics. So, it depending on the researcher need, we need to select this. There are certain sort of indicators by which you will understand that if the studies that you compare, if they are having too much of variation, and then that will give you some sort of index by which you can determine that okay, for this probably the fixed effect approach is not right. So, you have to go for random effects modeling. Now, finally, it will come like this. This is referred as a forest plot, and this is very important plot for all of you to understand, that suppose for 4 studies we have calculated the effect size out of the generic statistics. So, in this case like these are something like where it is going to give you the plot, and then it will also give you the summary combined intervention effect, which is denoted by this particular shape, and then this is basically the overall mean. Now, study 1 the effect size is 0.72, and where you can see this size of the square is basically the sample size considered in the study, and maybe like in this case the correlation has been taken. Now, in this case the sample size is more, in this case also it is the effect size it's very small, and that is why like depending on that you also get the relative weight to this. Then finally, you can see that the values, the resultant value is around 0.82. So, that means in all this particular study the correlation that has been studied and the generic statistics that have been considered for this. So, this is the combination. So, this way you can say even if the studies where you found the effect size of 1.02 or as low as 0.09, the resultant value is 0.82. So, this range is given, the values are like in between this. So, this is lower value and this is upper value, and this is actually your the statistics, that value. So in this case the generic statistics for each study is like, in this case standardized mean difference is calculated by this example. So this way we can definitely do certain sort of meta analysis for the studies which are reporting similar kind of findings, or maybe who have quantified some relationship between variables, and across studies you will find that okay, there is some sort of variation, and that variation may be due to sampling error, that may be due to the sample size selection, or maybe other effects. So we can apply either fixed effect method, or you can go for randomized effect method as well. Now this is towards end of this presentation, which is like talking about summarizing the overall utilization of the literature review, the types of literature review. So bibliometric analysis, where it is summarized the large quantities of bibliometric data. In this case we are not going to see the content, to present the state of intellectual structure and emerging trend. So here it is much more on the topic and all this publication, the year. We are not looking at the content of the paper, what is their methodology or something like that. So only with the bibliometric data we are doing the analysis, useful to identify the emerging trend, or maybe you can say that the publication. Now compared to that, systematic literature review, it summarizes and synthesizes the findings of existing literature. Here we will make a table, like we discussed in last lecture, that here we are making a table where you can report the method used in that study, the methodology, the sample size or the sampling technique. So that across different study you will get a summary that okay, what kind of method to be used for this kind of analysis, what kind of sampling techniques are preferred, what are the factors that we can consider. There are similarity among the factors, you can do a factor frequency analysis out of that through systematic literature review. Now coming to this, what we have discussed today, it's the meta analysis, where it summarizes the empirical evidence and the relationship between variables while uncovering the relationships not studied in the existing study. So in such cases, like the information they have reported in the past studies that we consider, we take those information, we extract it, we generate the generic statistics for those papers, and then we try to compute the effect size and the confidence interval, so that we can see that the homogeneity among the papers and their findings, and if there is too dispersed results, so then the heterogeneity as well. So this is also useful and quantifiable methods by which you can do a effective review of literature. To summarize, definitely we discuss what is meta analysis, then the advantage, and normally it is very effective for quantitative data. Then in this case definitely the steps before that, you have to select absolute like the papers that you require. So you also need to take help of this systematic literature review, then the prisma, so that you need to take the help of. Then steps involved in this analysis one after another, starting from generating the generic statistics, then identify that particular effect size, the treatment effect, etc. Then the methods as well, and then finally you are presenting the results as a forest plot. So with that we conclude this particular lecture here, and then we'll move forward to our next lecture, which is all referencing. This is very important because in this particular case we are going to understand that how to give citation to the the studied literature, or how to create the references. I'll also show you some demo of some kind of reference manager which are available like open source. You can use that effectively for your own literature review. So with that, thank you once again for joining the course. Hope this is going to help you in your research. So we'll be meeting in our next lecture, which is lecture number 15. referencing. Thank you.